Alright guys, good morning. So got your lesson here. Our last lesson for limits is today. Next class is going to be a review day opportunity for you guys before our test. So anyway, today we're talking about limits with e to the x and ln of x. Most of the limits we're going to be doing involve infinities of some kind. So let's go ahead and get started. Some stuff that I want to make sure you guys are aware of before we begin is what e to the x and ln of x look like at infinity. So first of all, it might help for you guys to be aware of what e to the x looks like as a graph. Okay, if you were to graph the function e to the x, it looks something like this, like all exponential functions do. They have a horizontal asymptote here. And so this kind of carries some weight with it here, okay? So, for instance, the limit as x approaches infinity for e to the x. What would that be? Well, that means as I go to the right forever, what does the y value do? Well, the answer is it goes up into infinity. And I guess maybe we should probably not say equals infinity. I don't know, I think it's probably fine, but we'll say goes to infinity, because infinity is not a number, so you can't really equal it technically. So we'll say the y value is approaching infinity. Now, what about the limit as x approaches negative infinity for the same function? That means I'm going to the left. Now, as I go to the left, I am approaching a specific y value, and that specific y value is 0. Okay, so there's some basic facts I'd like you guys to be aware of there. Let's also consider the graph of ln of x. All log functions kind of look the same. They have a vertical asymptote at 0, and then they kind of shoot off that way. Okay, so considering that then, what is the limit of ln of x as x approaches infinity? Well, better get rid of those equal signs because it's an infinity again. As I go to the right, it doesn't go up very fast, but it does keep rising higher and higher and higher as we move on into infinity. So the answer is it goes to infinity as well. Okay. Now, we can't say what's the limit of ln of x as x approaches negative infinity, because x can't approach negative infinity. It has a vertical asymptote. It's impossible for it to cross that line. But what it can approach is it can approach 0 from the right. So you might see this sometimes with a 0 with a plus. And in that case, as I approach 0 from the right, it drops down into negative infinity. So we'll say goes to negative infinity. So that's these 4 facts here are things that you might want to keep in mind for today's lesson, because I'm just going to say that's the answer when we get there. Okay, so you want to make sure you know that basic fact. These are some great facts to throw in a flashcard. I probably already did that. I'm not sure on those flashcards that I printed out for you. But now that we know that, we're going to take what we know here and we're going to put it together with L'Hopital and the properties of limits to just kind of work through a couple of sample problems involving limits of exponential functions and logarithmic functions. So this is kind of tiny writing, so I'm going to try to make it a little bit bigger for you guys to see. Okay, so take a moment, write down this problem. Now, first of all, when you're doing limits, you just take the limit of each piece separately when you're doing addition there. So the limit of 3 is just going to be 3, okay? Nothing special there. The limit of this guy, well, what I'm going to do is I'm going to plug in infinity for the x. Now 2 times infinity is infinity. And what this means, this is really not good math to write because you can't plug infinity in, but I've told you before, I like to do that just because it's easier. But what this really means is this means what we wrote earlier. This means we're taking the e function and we're approaching infinity. So I just like to write it like this. It's faster and it kind of makes sense. So what is e raised to the infinity power? In other words, what is the limit of e as x goes to infinity? The answer is infinity. So we have infinity here plus 3. Now what is infinity if you add 3 more to it? Guess what? It's infinity. So the answer is that the limit of this function as x approaches infinity is that it goes to infinity. Okay? A lot of our answers are going to be infinity today, but you got to watch out because it could be negative infinity. Some of them might trick us and turn out to be 0, or maybe even some other number, but a lot of them are going to be infinity today. All right, let's go ahead and do another one. Now, here, same thing, we're going to find the limit of -2 as x approaches negative infinity. Well, when you have a constant, you take the limit of it, just like on the last slide, it doesn't change. You know, if you have a constant, like say at negative, I didn't explain this last time, but I will here. If you have a constant function of -2, well, what is it at infinity? Well, it stays at 2. It never changes. So the limit of -2 as x approaches negative infinity is still -2. Here, we have a changing function, though. We've got an x in there. So let's go ahead and plug it in. Now, in this case, infinity times a number is just going to be infinity, right? But notice the double negatives. So actually, this is going to come out to be positive infinity because a negative times a negative is positive. And we've already talked about what e to the infinity is, right? It's infinity. But notice that negative in the front. So now it's negative infinity. What happens if you take negative infinity and you take 2 more away from it? Guess what? You still get negative infinity. So we won't say equals. We'll say goes to negative infinity. There you go. All right. How many problems am I going to throw at you? I think I have about 9 problems. We'll see. Let's do another one. And if you guys need to pause the video at any time to get the notes down, I just ask the sub to pause it and take your time. Here we go. Next one. All right. Once again, the limit of a constant is just that constant. Here, the limit of ln of x at infinity. Well, we talked about that earlier today. The limit of ln x at infinity is infinity. So direct substitution here is going to give me infinity on the top. And if you plug in infinity here, you get infinity squared, which is just infinity. So you have infinity on the bottom. Uh-oh, we have an indeterminate form. So this yields an indeterminate form. Indeterminate form. And the indeterminate form we're looking at is infinity over infinity. So guess what we do now? We do L'Hopital's rule. Okay? So let's go ahead and apply that. So we're going to say, therefore, this limit is the same thing as the following limit. The derivative of ln is 1 over x. The derivative of x squared is 2x squared. The derivative of 4 is 0, so we don't need the 4 anymore. Now, before I go any further here, let's simplify this complex fraction here. How do we do this? I'm going to multiply the top and the bottom by x. How's that? That way that goes away. And we end up with the following. The top is now just 1, and the bottom is 2x cubed. All right? So now let's do a direct substitution. We get 1 over, guess what, infinity. We've talked about that too. If you have a denominator that's approaching infinity, getting bigger and bigger and bigger, that fraction is approaching 0. So the answer is, final answer. I'm going to erase all this, so if you want to pause the video, go ahead. But the final answer is goes to, actually, we don't have to say goes to, do we? We actually got an answer this time, so we'll say equals 0. There you go. So that limit actually exists, and it's 0. Okay, let's go ahead and do another. All right. So direct sub leaves me with 4. Direct sub here leaves me with infinity. Direct sub here gives me infinity. And we have an indeterminate form. I'll put IF for shorthand. So guess what? We're going to do L'Hopital. So I'm going to take the derivative. If I take the derivative of the top, I get e to the x, doesn't change. If I take the derivative of the bottom, I get 4x cubed. If I take the derivative of 4, it's gone. Guess what? We still get infinity over infinity. So, guess what? We do L'Hopital again. Derivative of the top is e to the x. Derivative of the bottom is 12x squared. Guess what? Infinity over infinity. Now this is going to stop eventually, so don't lose hope. So we're going to, since we have infinity over infinity, we're going to take the derivative again. So derivative of e to the x is e to the x still. That's not changing. I lost my negative there last time. That should still be there. The bottom's 24x. All right, one more time, I promise. We're still getting infinity over infinity. This is the last time we're going to have to apply L'Hopital. So it's going to be the limit as x approaches infinity. The derivative of the top is still e to the x, but this time the bottom just becomes 24. And now we won't have to do L'Hopital again. Watch what happens. I plug this in, and I end up with negative e to the infinity over 24. As you guys already know, e to the infinity is infinity. So now I've got negative infinity over 24. And it doesn't matter what you divide infinity by, it's still going to be infinity. So the final answer is negative infinity. So final answer, this limit goes to negative infinity. Okay, so this one was kind of a pain in the butt because we had to take the derivative 4 times to get rid of that x on the bottom. And in the end, we just ended up with negative infinity. All right, let's do yet another one. Something similar is going to happen here. How many times do you think we're going to have to take the derivative on this one? Ponder that. All right, so first of all, the direct substitution here, that's limits 1. We end up with infinity over infinity. So we do L'Hopital. The first time we do L'Hopital, we get the following. The x squared becomes 2x. Don't forget your negative. The derivative e to the x is still e to the x. And the 1 is gone because the derivative of 1 is 0. Direct sub again. I'm writing this badly. Let me back up. We should be putting at least the limit here. The derivative of negative 2x is 2. E to the x is still e to the x. Okay, no more direct substitution on the top because that's just a number now. And the bottom is infinity. So what I'm left with now is negative 2 over infinity. And we've talked about this. No matter what number you have on the top, if you let the bottom of your fraction get bigger and bigger and bigger, it goes to 0. So this limit equals 0. Okay? All right. You guys are kind of getting the gist of things here, huh? It's either 0, infinity, or negative infinity. I think we can go ahead and skip this one. We've already done a problem like this, so we'll skip that one. Let's see. This one might be worth looking at. We've kind of already done one like that. I think we'll skip that one too. Let's take a look at this. Now this is different. This is different. So go ahead and write down this problem. All right. So first of all, we're approaching 1 from the right. Now, we talked about logs earlier today. We talked about approaching 0 from the right, but 1, well, what's the big deal about approaching 1 from the right? There's really no big deal at all. And if you guys have your continuity of common functions, you'll realize that LN's continuous. So there's really no reason we can't just do direct substitution here and get an answer. So let's plug some stuff in. We end up with, if I plug in 1, I get 1. And on the bottom, if I plug in 1, I get 0. And maybe you guys remember, maybe you don't. But if you have a number over 0, it's going to be infinity. So the answer for that one is infinity. All right, last one. Now this one is approaching 0 from the right. That's like what we talked about. As you approach ln as you approach 0 from the right on an ln function, it approaches negative infinity. So direct substitution here gives me negative infinity, and this gives me 0. Now let's interpret that. So when you have infinity on the bottom of any number, even if it's 0, the answer is 0. So there you go. Pretty chill. So that ends it. You guys can have a couple of practice problems from your homework that you're going to do tonight, and that's it. So happy weekend, happy test prepping. We'll see you Tuesday.